An important configuration parameter for a PID block is the controller action, the options being direct and reverse. This video presents the definition of controller action as used in the process industries and follows with examples for both options. The specification for controller action depends on the answer to the following question. On an increase in the PV, should the controller increase its output or should the controller decrease its output? Note specifically that the definition of controller action is based on the PV, not the control error E. There is a reason. By defining action on the PV, the definition can also be applied to regulators. Consider the hot air temperature controller. If the hot air temperature is increasing, should the controller increase the fuel valve opening or should the controller decrease the fuel valve opening? To slow or reverse the rate of increase in the hot air temperature, the firing rate to the furnace must be reduced. The controller must decrease the fuel valve opening. An increase in the PV requires a decrease in the controller output. The hot air temperature controller must be reverse acting, which is sometimes designated as increase-decrease. For the hot air temperature controller, open the configuration window, then open the Algorithm tab. The two options for controller action are direct acting and reverse acting. The controller action is correctly specified as reverse acting. Close the configuration window. Switch the hot air temperature controller to auto. Increase the fresh air flow by changing the fresh air damper opening to 65.8%. The hot air temperature initially drops, but the controller responds appropriately. The hot air temperature depends on the fuel flow and the fresh air flow. Instead of manipulating the fuel valve opening, the hot air temperature can be controlled by manipulating the fresh air damper opening. Let's switch to that configuration. If the hot air temperature is increasing, should the controller increase the fresh air damper opening or should the controller decrease the fresh air damper opening? To slow or reverse the rate of increase in the hot air temperature, the fresh air flow must be increased. The controller must increase the fresh air damper opening. The controller must be direct acting, sometimes designated increase or forward acting. Switch the controller to auto. Then increase the fuel flow by increasing the fuel valve opening to 87%. The hot air temperature initially increases, but the controller responds appropriately. As presented in the previous video, the comparator within the PID block computed the control error E as set point minus PV. How does the controller output change on an increase in the value of the PV? An increase in the PV decreases the control error E. That is, E becomes less positive or more negative. On a decrease in the control error E, the PID control logic in the modes block decreases the controller output M. Consequently, an increase in the PV causes the controller output to decrease. By the terminology used in the process industries, this controller is reverse acting. On an increase in the PV, a direct or forward acting controller increases its output. How can such behavior be achieved? One possibility is to reverse the inputs to the comparator. That is, the plus is on the PV and the minus is on the set point. The control error E is PV minus set point. When E is defined in this manner, an increase in the PV causes the control error E to increase, which causes the PID control logic to increase the controller output M. The controller is direct acting. In this series of videos, direct reverse action will always be implemented by reversing the inputs to the comparator. That is, direct action will be PV minus set point, and reverse action will be set point minus PV. The older pneumatic and electronic analog controllers implemented direct and reverse action this way. How do we know? By disassembling the hardware. How do digital controls implement direct and reverse action? Reversing the inputs to the comparator is one option, but in software other approaches are possible. Suppliers rarely provide such details, and from an application's perspective, how direct and reverse action is implemented is immaterial. It is essential that the controller action be configured correctly. Let's illustrate what happens if configured incorrectly. Switch the hot air temperature controller to manual. Then open the configuration window. Then open the Algorithm tab. Change the controller action to reverse, which is incorrect. Save the change. Then return the hot air temperature controller to auto. Now we need a disturbance. In the real world, loops are continually subjected to small disturbances. On a simulator, we must introduce one. Decrease the fuel valve opening from 87 to 86%. The fresh air damper is quickly driven fully open, and the hot air temperature drops rapidly. On reducing the fuel flow, the controller needs to decrease the opening of the fresh air damper. Instead, the incorrect controller action causes it to increase the damper opening. The next video examines the proportional mode of control.